Hi everyone, this is Ms. S. from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 8-1 on the Pythagorean Theorem and its converse. This is the vocabulary and important ideas we're going to be covering today, and these should all be in your notes. Alright, to begin with, let's start with the Pythagorean Theorem. The Pythagorean Theorem says that in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So the hypotenuse, remember, is always across from the right angle. So if you square everything and then you add the two legs together, you will always get the hypotenuse squared. A squared plus b squared equals c squared. Pythagorean triples are non-zero whole numbers that satisfy that equation. You can look them up on the internet and you'll find bunches of them, but here are some examples of Pythagorean triples. So they're just whole numbers that prove Pythagorean's theorem true. The converse of the Pythagorean theorem says the opposite of the Pythagorean theorem. So the Pythagorean theorem begins, if you have a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. The converse flips that around. If the square of the length of one side of a triangle is equal to the sum of the lengths of the other two sides, then the triangle is a right angle. So the theorem and its converse really do matter on what information they give you. So for Pythagorean theorem, they're going to give you that it's a right triangle, and then you know that this statement is true. Its converse is going to say this statement is true, therefore it's a right triangle. For the inequalities regarding triangles, the one that we've been working with is here in the middle, and this is a right triangle. So if c squared equals a squared plus b squared, we know it's a right triangle. But just like with a lot of other things, we can compare them. So for example, if we were to compare our heights, let's just say, I'm 5 feet 9 inches tall. So you might be equal to that height. You might be 5 feet 9 inches tall as well. Or you might be smaller than 5 feet 9 inches tall, or you might be taller than 5 feet 9 inches tall. The same holds true for triangles. Not all triangles are going to make this statement true. In fact, only right triangles make that statement true, where they're exactly equal. If the hypotenuse squared is less than a squared plus b squared up here, you have an acute triangle. All of the angles are smaller than 90 degrees. And if you have the hypotenuse squared greater than the sum of the squares of the legs, then you have an obtuse triangle where you have an angle that's greater than 90 degrees. So let's do some of your homework. This first question wants you to find the value of x and leave your answer in simplest radical form. So if you remember that the hypotenuse is always across from the right angle, that would be 18 squared would have to equal each of the legs, 15 and x squared, and added together. And then you'll solve this for x using algebra. And what you'll get is that the square root of 99 equals x, but you can break down that 99 into perfect squares. In fact, it breaks into 9 times 11, and 9 is a perfect square. Its square root is 3. So the 3 comes out from under the radical, and the 11 stays in, and your answer is 3 radical 11. Our next question wants to know if these numbers form a set of Pythagorean triples. So it is important to remember that the hypotenuse is always the largest number. So in this case, it'd be the 26. So you'd have the 10 squared plus the 24 squared would need to equal the 26 squared if this was a Pythagorean triple. And when you do the math here, what you see is that 676 on the left does equal 676 on the right. So these are Pythagorean triples. And our last one wants to know if this triangle is an obtuse, an acute, or a right triangle. So to begin with, we need to figure out which of these numbers is the largest, because that will be our hypotenuse. So if you use your calculator, or if you wanted to estimate, the square root of 11 is about 3.3, and the square root of 7 is about 2.6. Both of those are smaller than the 4. So the 4 would be our hypotenuse. So 4 squared is going to be something to the square root of 11 squared, plus the square root of 7 squared. And this is what we're looking for here. Is it equal, is it greater than, or is it less than? And when you do the math here, the square root of 11 squared is 11, and the square root of 7 squared is 7, and 11 plus 7 is 18. So what is the relationship between a 16 and an 18? And the answer is that 16 is less than 18, which makes this an acute triangle. Good luck, everybody. I hope you guys all do great.